Okay,
Matt's
Matt's
start
gonna
off
be,
with Matt.
yep.
Yeah, sorry.
Yep.
Matt Oman's going to take it off now.
Okay, let me get my screen shared here. Should be coming.
We can
Looks
see
great.
it.
Yeah, let me see. Get my camera on so you can all see me. Okay, well, yeah, I talked to Kyle and I wasn't exactly sure what I wanted to do or how I wanted to share this. But so I threw this together and let's kind of walk through it. So like we said before, just feel free to ask any questions if you want and I'll do what I can, but I'm not monitoring right now. I'm just looking at my one screen. So I'm with Matthew Construction and we've had our device since last summer. And so I've been using it mostly as, a contractor QC type tool. But we did the project this year, as you can see here on Trunk Highway 21. We paved between May 21st and June 9th. It was a mill and overlay with a 1.5 inch mill and then 2 1.5 inch lifts. And I noted those on here just mainly because of yesterday's conversation and even this morning's now about the 1.5 inch lift. So we'll get into some of this at the end. Kyle did show some of this data through his presentations yesterday, indirectly, and some of his examples, but you can see for the most part, it did work pretty well with that 1.5 inch lift, but again, it was over a milled surface. So we did like Kyle has mentioned, we did the lab portion of it, and we cannot buy that equipment yet. So we borrowed MnDOT's, and this is a picture of actually Kyle's stuff. But we ran all of our production pucks. We did dielectric profiling on before we dunked those. We also made extra pucks each day. At the beginning of the day, we made about a 91% give or take and about an 89%, which we just took 250 grams and 500 grams off. So as yesterday noted, maybe that second one should be more like 400 grams off, but we just did these two and they seem to work fairly well. Again, 91 and 89% give or take. And we just compacted those to the same height as we had for the production pucks for that day. So it worked well. Like I said, it kind of fit into the process pretty quickly. The staff jumped onto it and got used to it and just put it in their process so they would catch this before they dunked it. And beyond that, it really wasn't that much of an addition or anything to interrupt their process. So in the field, it was a closed 2-lane road, closed with flaggers. So we had pilot car with flaggers, which has been noted on a couple of the other presentations, which does make some differences. In this case, we had milling, prep, tack, paving, and rolling all within that flagger zone. So it got to be pretty long. So we set this up way back then with Kyle and Di to have the 500-foot segments in case we needed to jump with the flaggers as we were moving forward. We didn't know exactly how long we'd be able to go. So when we set this up, we had it as a joint swerve. That way we were trying to catch to meet the requirements for Kyle's group with the swerve for verification, and we collected our data, and at the same time Kyle had people out there with another device and they were collecting. So they were collecting joint straight with some swerves intermittently. So we were collecting 2 different data sets. But after a couple of days of collecting, Rebecca's group in the AMT requested the change just because going through the analysis in Veda, it just works a whole lot better with the straight line passes with 3 straight passes. So then we switched to the joint with basically 3 straight passes on the mat, and we did swerves at the beginning and ending into the days to get our verification. The one thing I skipped over there was when we also supported the change from the swerve because when we started, I hadn't seen the new software, and as some of you probably know, you can't see data during the swerve module. So you're just seeing your distance, and when you're done, it pops up with the 3 values for the sensors, but you can't see your data. So from our standpoint, looking at it from a contractor, we couldn't see how we were doing, on the fly. We also, on this project, we integrated this with pretty much everything else we had, and from a QC level, just checking things out, not running it through Beta. We also had the non-nuke out there as part of our process, and we were comparing with that. We also had paper mounted thermal profiling, intelligent compaction, and e-ticketing. So we kind of had we ran the gamut on this one. But again, in this, what I was doing, we were just looking at this kind of, as I call it, the QC level, just checking things, but not doing the processing or post-processing. So a big part of this is just data management. And I've used Veda before, but we hadn't used this with Veda yet. And so we weren't naming the files in that format. And after a couple of days, we talked with Rebecca's group again and revised all of that to get the file naming correct, so the file processing can happen easier in Veda. The other thing here is pretty basic, but it's very important. Documentation of what's going on, and it could be anything from precipitation that happens because the moisture will affect the results. Just notes if the plant is down, if a paver or a roller stopped for a bit, whatever it might be. There's just any notes you can have to kind of help look at this data. If we pick this up a year from now and try to reanalyze this, you wouldn't have any idea. So just kind of keeping these basic notes. We did have times where we had to temporarily remove a sensor. So if we had just 2 sensors, well, now we wanted to know, maybe it'll help why it was out. As Kyle indicated yesterday, we had some GPS errors out there, just things like that. Just from a high level, our contract didn't have any data analysis. People who know me obviously know I like to do the data analysis too, but in this case, we were just collecting data. So just some general comments on this project. We did have, and this has happened before, but it seemed to be more common on this project for whatever reason, but the sensors would just all of a sudden disconnect, and people who've used it have seen that on the screen with the RDM 2.0. It just pops up and says sensor 192 or whatever has been disconnected, and it just like that, it'll go out, and then you'll back everything out of there, start back up again, and then it'll work again. So I don't know what causes that, but I've talked to them throughout the summer, and we've updated it, and it has gotten better. So the other thing we had here was kind of had what I call the hanging air calibration. So we were out in the mornings, 5:30 or 6, trying to catch the cores and jump ahead of the core and crew with our flaggers with that. And so it's very stressful, and we're trying to crank these out, and then that calibration was failing, and it would just kind of get stuck in this loop. And it turned out to be something that was tied with the survey wheel connection. So we ended up just switching that and putting it on a different sensor, and then it actually worked. So I don't know, that's as far as I've resolved it. GSSI had never seen or heard of that before, but that's what happened, and it worked, fixing it that way. And then again, as I said, we couldn't view that data real time during those swerve passes. So when we were doing joint swerve, we were not seeing 2/3 of our data on the fly. So that was just some of those that we changed. As I said before, we had some GPS data connectivity with our device. I've got the one that came with it, which works perfectly fine for everything I've done in the past. But when you're trying to get into Veda level, it just doesn't work. So we ended up using a sensor or an antenna and a controller from MnDOT, which did work well. Kyle had to troubleshoot a few things to get it to connect, but then as has been pointed out several times, there's just the safety concerns on these busy roads with the 2-lane flagger. And in this case, again, we had some fairly long closure segments just because the milling, cleaning, tack, paving, rolling, and DPS all fitting into that closure. So it did get a little stretched out. So we had some, maybe 15, 20 minutes. So you've got drivers that are now upset sitting there for that long. And so it just becomes, something you've got to be aware of, especially when, portions of the time you're walking with your back to traffic. So just as everyone's pointed out, it's just something to be concerned about. So some of the keys we had for success out there was the training. So those are the 2 people that we had running the data, is Trevor and Alex, and they'd never used it before. And so Kyle and I, I could have just as well been out there using it myself, but we wanted to try to implement with staff that hadn't been familiar with it before, just because that's how it will be implemented. So we had trained in Trevor, he was going, and then things switched, and now he had to go out. And so then we had to train Alex. So it was actually a great experience to see how things would go, bringing a new person in, from an implementing standpoint. So it worked pretty well. We had to just be patient with some of these, with data collection. Early on, there was some of this where we were failing some of the swerves, where if we were, we weren't being extra conscious with our path and you get too far out or you don't have enough, and we were just not getting those sensors to match within that tolerance. So then you rerun it. Also, we had if sensors were just disconnecting, you got to start over again. But basically, that was pretty well once we got it figured out. That's kind of the part of the 100% functioning. If those sensors just quit or disconnect, then you're going to just start that whole pass over again. We had some weather before the drought of 2021. We had quite a bit of rain during this project, so that does, as we said, of course, affect paving, but it also affects our DPS collection because of the surface, and then the traffic, as I mentioned, where we've got long segments, and it did affect some of our collection. So the collaboration in the end is really what it comes down to: collaboration and communication. And in this case, we were doing lab data, so it worked with our lab staff, trying not to disrupt their normal days, collaborating with them, and they were very good to work with us, with the paving crew. You go out to a job who's never seen this before, and even though I'm working with the same people, you just always got to make sure you work with them so they understand what we're doing. Of course, in this case, MnDOT was out there, as you can see in that picture. We just had a lot of people on site. We're also tying it with our field QC, so we're doing our normal QC process as we're going, and then tying it with our project managers, the leaders, and then MnDOT District 6 through the change order, and then Kyle in the central office. So just a lot of pieces to it, but you got to keep on top of that the whole way through to make it smooth. So here's just some final thoughts on DPS in general. So obviously this has all been about QA or acceptance. So in this case, we're following the cold roller. It's more what I would look at as just an evaluation or 100% evaluation and documentation, and you're not part of any process. In that case, then you require highly accurate, precise, and verified data, whether it's GPS, sensor 1, 2, 3, everything has to be verified and very accurate, precise. It does also require careful data management and then the analysis, which of course in this case we didn't do, but implementing it down the road, it does require a whole nother level of analysis and expertise, which is considerable user training to get someone up to speed to do all that data management, but then particularly the analysis. The cart configuration works fine for this 100% data coverage. It's got safety, a lot of walking. If you like getting steps in, it's fine, but it does, so it works for that. The core specific locations that Kyle mentioned that did get a little cumbersome and awkward. Trying to cruise around at 5:30 or 6 in the morning and staying ahead of the core crew, and then loading and unloading this out of a truck, whether you tear it down, it's not very portable. So from a QC standpoint, so this is the kind of the way I've used it. It doesn't require a lot of user training to get up to speed to collect the data. The cart, as I said, is difficult to use to evaluate process control wise. And you can see in the picture there, I've tried to run it over the hot. That hasn't even been rolled yet at all there. Tried to go over the hot and the sensors roll overheat and then quit. So from a quality control, process control, it hasn't quite gotten that perfected for me. We can go through in the lower picture and hit cores that were done the day before and measure within a foot longitudinally, and there's probably not enough variation to affect. And it gets me some numbers that I can use that from a process control, I can evaluate and say, hey, thumbs up, we're doing a good job, or we need to look at whatever it might be. It does work for process control between the intermediate and cold rollers. A lot of times I'm out there just using time mode and just running the sensor and finding areas, going over, finding the low spot or high spot or whatever, trying to figure something out. And then we, check it with our non-nuke or other device. And then when I'm done, I don't even save the file. I'm just doing it for real time, checking whatever locations I want to go. Of course, roller water does affect those measurements. So that's just something that you've got to be conscious of. The lab equipment, like I said, we can't buy it yet, but I really love this aspect of it. For me, it provides really good correlations to our densities with our core densities. On our project on 21, it worked really well, as Kyle has showed, but I did use this for a different project, and it worked really well, even with just a couple pucks at different airborne levels. gives again a process control, which doesn't require the QA, all the high level accuracies, all that. It gets us within a ballpark at a very high confidence level to go through our process and say we're doing a good job. The negatives, of course, is in this case now you probably would need 2 RDM controllers. There's an additional cost for that. There's additional cost for this for a 4th sensor. You'd need to have a full setup. So yeah, I mean, you could run with 2 sensors on your cart, but that's just another consideration. And then you'd have to have it set up at your lab permanently. So maybe eventually every lab would have to have it. So depends on the implementation of how it goes, but we did learn that water can affect these measurements. If it does go in, inadvertently, it can affect those numbers for a day or up to even several weeks, depending on the aggregate type. So just some parting thoughts. This is a great documentation tool. You can go through and get your whole project or whatever, however much paving you've done, you can collect that even several days later. It does provide fun data analysis opportunities. Some of us like that more than others. As I said, the cart configuration is mobile and it works fine. It's just not very portable. And so then I've said this before to Kyle, and just something like a weed trimmer or a metal detector is kind of basically a handheld type device, something that we could just walk around with and pick and choose spots here and there and really not be concerned with recording the data. And that's looking at, like I said, for QC more. Yesterday, NCAT's presentation did talk about the less than 2-inch lifts can be affected by the underlying material. As we showed, it was okay on 21, but that was over a milled surface. So, what about other surfaces? I know I've seen CIR have drastic differences, like was pointed out by North Dakota earlier this morning. I've also seen over concrete that those numbers are affected by about that 1.5, maybe 1.4 inches. So with that, the project selection guidelines in an implementation planning, is this, a blanket treatment, or is this only on certain jobs? And just something to consider on project selection guidelines. And then, finally, will agencies who implement this plan on capturing and quantifying these pavement performance benefits from DPS and improve quality, and then incorporate those into those LCCA calculations to reflect these benefits? So that's it. If there's any questions.
Well, that was great work, Matt. Thank you very much. Yeah, I'll say we got very fortunate to have the contractors we had this summer. Matt's group could have quit probably on that project with some of the stuff that was thrown at them. And I appreciate them fighting through it and getting actually really good data on that 21 project. Richard Hamilton said, did you use the same antenna for lab scan that you used for core scans? And if not, was any correction applied?
I did not use the same antenna. I actually switched because we had gotten another one from Kyle. And so there's, of course, when you go back and look through the data, you can always see this, the sensor identifications on there, but I didn't do any corrections. And I don't know if Kyle had done that either, but I did actually run it one day. I ran the same pucks using 2 different sensors to see if that affected. And I didn't, from just quick looking at the data, I didn't see much of a difference. So I didn't dive in.
And I can add that NCAT's shown the same thing, where for the puck testing, it really doesn't matter what sensor you're using. They're all basically right on top of each other, and that'll come out as part of the precision and bias study that NCAT is doing. You shouldn't have to do a correction for the lab. Robert Hinman said, Matt, any notes on asphalt plant production? For example, when the plant had to burn off higher than usual aggregate moisture, which might lead to some increase in asphalt binder absorption, or when there was more significant bin or gradation changes? If so, did you notice an increase in variability?
I didn't look at that. That's something we can do this winter.
Yeah.
But as part of this project, we weren't doing the data analysis. So if Kyle and I this winter we want to dive into that, we certainly can. I've got all of that information. He's got all the data, so we could look into that. So Kyle and I can stay in touch.
And Robert, that's a great question, because that's something that UNH is going to be looking at, and we'll be building that master database for them to go through, So we'll definitely be working with you on that, Matt, if you're willing. We better move on to Bryce's presentation next. Thanks a lot, Matt, for your time, and hopefully if you stick around, there'll be more questions too that we can answer later. So go ahead and share your screen, Bryce. Okay, I'll let you get right into it, Bryce. Go ahead.
Okay, can you hear me all right?
Yes.
See everything fine? Okay, yes, I'm Bryce Worry, owner of PaveWise and Worry Consulting. We specialize in helping contractors consulting with technology tools, quality control, and we run a PaveScan 2.0 for the last 2 years as one of our quality control tools, and we've had great luck with it. In the 2021 season here, we're fortunate enough to make it to 6 states, 4 contractors, 21 projects, and we use it more as a quality control tool, again, kind of like Matt there, for verifications and just roller procedures and kind of just to collect data. But we've had very good success with it and happy to share some of that. Again, here's just a few of the projects. Montana project, a couple Wyoming projects, a few North Dakota. We use it a lot at airports. 401, 403 mix, dense graded mixes. We've had good success with them. Open graded mixes in Montana. We have a 19.5 millimeter, 6428 oil. We struggled a little bit on this project with collecting consistent data. It was kind of a unique project that it was only an 1.5 inch lift with a 19.5 millimeter mix, kind of first time we've ever seen that. It did work, but the consistency in the data we noticed was quite a bit more, wasn't there like it was on a 12.5 millimeter or a dense graded airport mix. We use it a lot in Wyoming just because there's test strips there prior to mainline production, so you can kind of get your roll pattern set up, everything, do your calibrations. We do have a test puck kit, so we test the pucks, set that up, do our verifications, and then we also do the cores prior to extraction, just to kind of do a second verification and get that really dialed in. Couple North Dakota projects with FAA mix, really good results on that. We'll talk more. John from the North Dakota DOT talked about the Highway 8 project a little bit, and we'll talk more. We actually were fortunate enough to measure 26 miles of the longitudinal joint on that project there, and we're still going through the data. But yeah, we really got out there and did some testing, and we really have had good success with this tool and other projects. We've struggled a little bit, and there seems to be a common theme with the ones that we do struggle with are more of a gap graded, larger aggregate, or the aggregate source is more of a quarry rock. Wyoming, there's a lot of quarry rock down there, really dense rock, and that's where we kind of see this struggle a little bit. So let's see here. So just some DPS data that we did collect up in the right. That was Toby, actually a density technician for Northern Improvement. So we did have 4 contractors that use this. They actually would just use mine. I have a single sensor machine, but we train them, do our calibrations on cores and the puck kit, and walk with a nuke gauge and kind of just show them how it works. It is pretty user friendly once you get the calibrations correct and understand what you're actually using it for. But on Highway 8, we did get to take 26 miles of longitudinal joint data. One of the biggest reasons that we decided to do that was this project, the contractor averaged a 94.2 on the longitudinal joint, which was outstanding. So we really wanted to collect that data for research and see how the DPS kind of matched up to it, because we did get over 100 longitudinal core locations collected prior to extraction on this project as well. And then we did test 26 gyratory pucks with the puck kit. So, and that's down on the right. You can see my collection of gyratory pucks. I'm sure some other people's labs look like that, but we collected tons of gyratory pucks. I actually got about 150 gyratory pucks sitting in my lab right now from this past season. So pretty fun to test those and check them out. The Highway 8 85 Lingle to Lust project was unique too. Like I said before, Wyoming has a wide range of aggregates down there. This specific project had came from a pit called the Guernsby pit, and it had really dense aggregate in it. I think it was called dolomite and some limestone and some granite and really dense rock. And we were actually picking up dielectrics of over 7.5 with our DPS on this project. And it was one that we kind of did struggle with. We just the range of dielectric that we'd get on this was really all over the place. Once we calibrated on a specific joint, it would actually be quite a bit more accurate. Go back here, and then we use this tool on airports all the time. Get really good results with airports. We were fortunate enough to do a full scan on airport runway and 28 gyratory pucks and 136 joint, and we have really good success with getting accurate data on dense graded 401, 403 mixes. So, but for the year we did 133 miles of collection on longitudinal or mat was scanned with the DPS, and over 1,300 core locations were scanned for quality control on over 21 projects. Some of the QC contractor DPS benefits as a density technician, and this is how we use it, not for quality assurance, but quality control, setting up the paving procedures. You can use it for roller compaction uniformity pattern setup. So what we're trying to do, especially on PWL, is keep as consistent as possible from center line to shoulder, so we can move the free pass of that each roller into where we need to concentrate more. And that's typically where we cut the mat transversely from center line to shoulder, and kind of can see where we need to concentrate more. Core evaluation, we use it for that, and verification. Longitudinal center line accuracy, it seems to produce more accuracy than a nuke gauge on center line, depending on the type of, if it's vertical or if it's a notch wedge. We typically, 90% of the projects we do is notch wedge joint construction. So, but on the bottom left, we're actually using it for prior to extraction on that core location where we're doing a time, and then we'll actually use the distance or the core method to collect that data, both of them, and compare them prior to extraction. On the right, Toby's actually got his non-nuke checking a spot that the DPS picked up that might be out of our variation of what we think is acceptable. So DPS accuracy in the field, I don't want to call it quite accuracy, but consistency of the DPS depends on project mix type and conditions during production. What I mean by that is, and I know John talked about this and a few other people have, but as the day goes on, the plant might be ramped up to 200 tons per hour in the morning, 300, 400, 500, and then ramp back down. And as those plants are changing production, gradations can change a little bit, AC can change a little bit, and you can actually see a little bit of that adjustment with the DPS. On that Highway 8 project, that project had over 2.5, 3 inches more rain than normal. So in the aggregate, we were battling 7 to 10% moisture. So in the morning, once we'd get into the pile, it'd be pretty wet, and then as we got into the pile, it would dry out. So we'd have to make AC adjustments. We couldn't run our plant to the full production because of drying that aggregate. We had moisture in the mix, and so you could see that stuff with the DPS as the day went on, and from day to day, when we did get rain, when we didn't, we'd have to calibrate daily or twice a day with the test puck to kind of get that accurate. We have seen a lot of projects with lime evotherm fibers, and we haven't seen any of those affect the results, the data of the DPS. The one Wyoming project, we had 2 different type of fibers, and we were fortunate to run them, both those sections and the section without it, and the DPS really didn't, the data didn't change from one to the next. That's the same with lime and evotherm wrap, of course, too. So AC, polymer versus standard, haven't seen the DPS really change any data or see anything that it likes compared one to the other. This is just a video of it going into the mix there. We have noticed a little bit that higher AC content does seem to produce more consistent or better results with the DPS, and that's just what we've noticed, and that's partially more, I should say, higher AC and denser graded mixes, like up on the top, so 403 dense graded compared to that 19.5 millimeter on the bottom, or larger aggregates, a little more gap graded. And then we definitely have noticed top lift data is way better than, say, base lifts. So as you go up with your lifts, you will see more consistent data. I don't want to say it's more accurate, but you kind of get rid of those peaks and those rises in data that you might see on a base lift compared to the top lift. So some of the logistics or issues that we see or have had with this, and this is contractors that have brought them up to us running it and just out there on the project, is collecting the data. It must be collected in safe zones or behind the paving train. That isn't always possible depending on the project logistics. When you have a paver going 30, 50 feet per minute down the road, and you got to take 2 swipes and do your calibrations and keep up, and then, I mean, it's really difficult. It's hard to stay in those closure zones. And they're putting out almost 4 or 5 miles of asphalt in one day, you know, depending on the width. If they're a 12-foot driving lane, 2-foot shoulder, I mean, they're really moving 450, 500 tons per hour. It's a full-time job. 2 people actually have to, we found out, have to really be dedicated to it to be successful. It's lots of exercise. Safety concerns, of course, we've heard a lot about them, but shooting on that centerline joint data can be really difficult and almost impossible under construction or in open traffic. Night paving's difficult. You have to have a spotter. We do a lot of paving out in Montana and Wyoming, where you got mountains and curves, and it's very dangerous with traffic. And typically that's how a lot of projects we're doing. They're flaggers. There's a pilot car, but a lot of times it's the actual truck traffic, the mixed trucks, that you have to worry about. This specific project here up on the left, we had 45 trucks hauling, you know, so 450, 500 tons, there's a truck going by about every 10 seconds. So safety concerns, big issue. It works good in airports or closed projects where you don't have to worry about that. You can concentrate and collect data, and it's a one-person job. But mainline public roads, it's definitely a concern. Some of the DPS logistic ideas that have been out there, people are kind of coming up with. Obviously, we know logistics of collecting the data is a big issue. The University of Illinois has mounted some GPRs on a correction roller down on the right. I haven't talked to them too much, just a little bit, but it sounds like they're getting decent results and collecting data with that. The biggest issue is managing water from the rollers. We actually created this one up on the top here. It uses the exhaust outflow from the diesel engine and blows the water away from the sensor in front of it, almost like a leaf blower. And it does work. The issue we're having is we're getting distortion and we're getting too close to the metal there and to the machine. So we can collect data with it. It's just not accurate data. So we have some things to figure out there. But what was neat about this is we actually linked it up, time-stamped it with the intelligent compaction. So we had RTK, real-time location of the roller, of that unit. We had CMV values. We had all the intelligent compaction data along with the DPS data, running it in just a time mode. So it was kind of neat to see that. And, you know, this is what contractors are really going to want. If they got to collect the data, is putting it on something they already have, or using it with something or somebody that's already got a job there. Having 2 more people pushing a cart and running and taking care of all this is just, a lot of them, that's the biggest issue I see working with contractors, is I got to hire 2 more people to run this cart and do this, and the logistics and the safety of it is just the biggest things that we always hear. And it has to be mounted to a finisher correction roller to manage that water the most effectively. Here's a video of it just running. not too far behind the paver. You'll see here, we're in that closure zone, but it's got potential. It's got potential. We still got some things to figure out, but logistically, I think it's kind of the future of collecting some data for contractors anyways. Just some DPS conclusions, pros. You get a full assessment of the asphalt mat with continuous coverage. You can see what you need to do to make adjustments to the paver, to the roller trains, frequency amplitudes of that roller to get it the compaction the most consistent across the whole mat. Great quality control tool, roller pattern setup like I just discussed. It's non-destructive. It's easy to use. You know, half a day of training with most of the technicians I worked with, they were pretty comfortable with it and did a really good job. Of course, the cons, logistics, safety, accuracy and calibrations, and then some of the things that we can't control, field conditions, weather, moisture in the mix, and plant slowdown, speeds up. I actually was on one project where we had two separate plants running. So plant A, plant B, 800 tons per hour, and you're getting mix from both of them. And the gyratory, the pucks actually were pretty similar, but say one of those plants started getting big bin gradation changes or had to adjust AC to keep up with the production, then you know, that data that you're getting out there might be a little bit skewed depending on which gyratory puck, which mix you're getting the plant from. You know, those changes, we have seen a little bit of the changes with the DPS data. So that's all I have. If there's any questions.
Well, thank you very much, Bryce. I know I was excited to see you looking into attaching it to the finished roller. And the idea with the exhaust is a great one too. And I'm probably not alone with being excited about that as a potential new direction for the technology. I didn't see any additional questions in the chat, and we are right on our 40 minutes after time frame. So maybe think of questions for Bryce and Matt while we have Mitch give a few of his thoughts. Euland Brothers did an outstanding job collecting a ton of data this year, and Mitch has some thoughts that I think are critical to getting this technology to a point where we can use it for acceptance. So go ahead, Mitch.
Hi, Kyle. Yeah, we had a couple projects that we used this on. One was road closed and one was under flaggers. And I'm afraid I'll be echoing quite a bit of what's probably already been said about, you know, number one concern here is safety. If you have to have another person exposed to not just you know, truck traffic that's involved with the paver, but also the civilian traffic, if you want to call it that, you know, residential traffic around. That's definitely a aspect that I think needs to be looked at if this is really being deployed. That's all I'm going to say about that, because I think you probably all heard about plenty about safety so far and everybody's concerns on that. But one of the biggest things that we saw is vendor support could be an issue that certainly needs to be addressed before this is really deployed full scale as an acceptance tool. Kind of in our opinion, the vendors of these products, these pavement scanners, need to understand that this piece of equipment, if it's being used for acceptance, is as important as the paver or the rollers, or, you know, you name it on the grade. So they need to kind of maybe think more along the line of like a vendor of Caterpillar, like a Ziegler Caterpillar, or, you know, Gencor, or, you know, anybody that's actually in the business of selling construction equipment not construction testing equipment. That's really kind of, like I say, our biggest thing needs to be considered. I know Bryce touched on attaching the system to rollers, and that would probably be the easiest, best way to get actual contractors to buy into this and use it as a construction tool instead of an acceptance tool. And that would probably be the direction that we would like to see it go as well. There's really not, I mean, there's definitely merit to the technology, and there's applications for us to use it, but it's not as appealing to us as it would be if it was real time, where you could actually look at intermediate rollers and also the finish roller.
Oh, did we lose
Kyle,
you,
is
Mitch?
there, what's that?
Did we lose you, or is that all you had to say for now?
Yeah, is there something else you'd like me to touch on, or what?
No, I think it was all good thoughts, and like you said, we have touched on a lot of those things, and it's just good to hear perspective from Yulin Brothers and other contractors who are having to use this equipment for their day-to-day operations, what's going to be required to get it to deployment. So I appreciate you sharing that. And we'd also like to give advanced testing a little bit of time to share their experience. I know they've been contracted by New York DOT to collect data, and anything additional you have to share would be great, Rich.
Sure. Can you hear me?
Yep.
Okay, great. So as was just mentioned, we're working with DOT. This year, 11 projects were awarded, but I only have records of covering 7 of them. So we either totally forgot to report on several projects, or they were pushed to next year. These projects ranged from up north in New York State in the Watertown area, down south in the Southern Tier and Deposit. We were in the Finger Lakes, we were near Syracuse, and we also did a couple jobs in the Catskills, so we were all over. I added up the total lane feet of data collected, and we had just under 511,000 feet, so just under 100 miles. So that was on 66 paving days over the 2021 season. And just to throw another number out there, I think I lost about 35 pounds. So my wife is pretty happy with that, but as others have mentioned, it is quite a vigorous activity. So when people ask me how it works, what I usually tell them is, well, it works great when it works, and when it doesn't work, okay. And that I will just add to the frustration of some others. We have gone ahead and purchased extra batteries. There's no way you're going to run a 12-hour paving day with just 2. We actually have a generator we supply for our operators so they can charge in between if it's possible. Over this past season, we've had to swap out 3 sensors, and so that's been an issue. 2 of those have been repaired, but we're still in the process of verifying those repairs. So we're also considering potentially purchasing an extra sensor just to have it as a backup if this keeps happening. We also had to replace a concentrator box this year, along with multiple software glitches. So we had 4 operators trained how to do this. They ranged in age from 20-something all the way up to middle-aged adults. And I think the most salient characteristic of your operator is they have to be patient, because inevitably they're going to run into something that doesn't work right, and being able to troubleshoot that in the field when you're under pressure to get data collected can be a little stressful, to say the least. Others have mentioned traffic control, and this is very important. You have to coordinate with traffic control because you're back there in the pattern, obviously. We've also had some issues with not being able to measure core locations because they're not laid out until we've already moved the pattern up. And, you know, there's no way I'm going to be able to load this thing back in a vehicle and pull it back in the area where there's no more any traffic protection and run scans. So the core layouts really have to be synchronous with the work. Otherwise, it becomes challenging to collect that data. Other than that, I mean, it's really amazing. What I've noticed in collecting data is there's a lot more variation in density than I think we expect or suspect. And, you know, given the fact that we've historically looked at core densities to measure the actual acceptability of the product, I wonder if those have been necessarily accurate given the degree of variation I've seen on some jobs. Now, I can't attribute what really is the source of those variations, whether it's mixed property, whether it's how they're paving, whether it's changing roller pattern, because when I'm collecting data in the back, I have no opportunity to observe any of that. So if you're going to try to tie any kind of reasoning behind that variation, you're going to need more than one person on a job. I heard someone else say that earlier, and I will echo that. If you're going to use this for any kind of QC purpose, you're going to need a couple of people to be able to deal with the information. So, you know, like I say, it's great when it works, and very frustrating when it doesn't work. I think we had 4 production days where we ran with 2 sensors. And one key thing that we learned on the last job, and I'll end with this, first day of paving, we had to wait to start because temperatures were right around freezing. I had the unit stored in a van, and the way we mobilize is we roll it right into the back of a van on a ramp. Well, that thing sat in the cold overnight, and I had a hell of a time getting it to turn on and recognize sensors for the next hour. So in consultation with the vendor, we put it back in the van, cranked up the heat to like 90, and what I ended up doing is running the initial connections inside the van with the heat blasting to the point where I got to my calibrations. Then I rolled it out and I was able to calibrate. But I think on the first day of that job, I lost probably about 1,200 feet of data collection because of that temperature issue. So the cold is not happy. It doesn't make the sensors too happy, apparently. So we learned our lesson there. The second morning, we went out and we had preheated the unit in the van and everything worked fine. So if you're doing any cold weather paving, that's something to keep in mind.
Thank you very much, Rich. And thank you to the whole group of contractors and consultants here. That's getting that sort of perspective is very important for us. So I appreciate it. Craig just put a comment up there that they had the same issue with the 2 years ago, and they had to take it into the garage to warm up. And towards the end of the season, we also had a similar issue. Luckily, most people don't like to pave when it's that cold either, but that is something to be aware of. And I do want to mention before we bring it to Steve that I think we can use that 35 lost pounds as part of our marketing campaign for the DPS. So if we can get a before and after picture, that'd be great, Rich.
All right, you got it.
All right. So, well, with that, we're pretty much right on time, and we're ready to kick it to Steve. He ran a really nice implementation planning workshop, and a lot of you were involved in that. And we wanted to just give Steve some time to give us a little bit of a summary and recommendations that came from that. So take it away, Steve. And we can see your slides. Well, it just disappeared. There it is right there.
You can. Okay, very good. All right. And nice discussion, Rich. I really appreciate that feedback. Very interesting. And you know, I can say I also lost a lot of weight when I visited Rich Giesel in Alaska. That's a great tool for losing weight, that's for sure. A little bit of background. As Sharp 2 was winding down and before Minnesota DOT could get the DPS Pool Fund Research Project going, Idaho Highway established a task order with QES to assist during the interim with communication. And one of their tasks was to conduct the DPS implementation planning workshop, a roadmap of sorts that we hope would aid in advancing this national effort and also assist with the state agency for advancing its use. So I know a number of you were invited to this workshop. It was held in April of this year, and special thanks to QES and Brian Prowl for organizing and facilitating the event. But I know a few of you were not at this event, so I was asked to just spend a few minutes to summarize the findings of the workshop with really emphasis on the gaps that were captured, and hopefully that'll tie into the next two agenda topics. So, of course, federal highway, we have to have our disclaimers when we have external presentations provided. So there's the disclaimer, and we also have to have the acronym. So there you go, you saw that. But the workshop itself, you know, our desired outcome was to gather stakeholder feedback and establish an acceptable path moving forward to implement DPS for acceptance of in-place density. But the main thing is we wanted to obtain your feedback on what should be focused on in the future to meet those goals. So the highlights of the event, like I said, it was held in April. It was a 2-day virtual event. The participants that we invited, they were pretty select. I mean, we wanted folks that had experience with DPS technology. So we had 8 federal highway, we had 12 of the agencies invited. We had some consultants, some contractors, 2 academia. We had NCAT, UNR, and we also had industry was there, the Asphalt Institute and NAPA. The agenda itself, we did have federal highway, Dennis DeVork. He talked considerably about what the federal highway requirements are for acceptance. We heard from our 3 lead agencies, Alaska, Ohio, Minnesota. But then we really got into it as far as, you know, what were the barriers and gaps facing implementation. The report itself, afterwards, it was finalized and provided to all the participants of the event. And you know, in summary, there has been a lot of progress in this technology, but we do know there's a lot of gaps still remaining with this technology, primarily in research. So right now we left the document final, but we also gave it to Minnesota. And one of the things that you know, we're going to talk to Kyle and Di is, you know, let's go ahead and revisit this document near the end of the pool fund, because we know there's a lot of holes in it right now. So let's talk about some of the gaps that were identified. And Craig talked about this a little bit about core correlation issues. And that's a hot topic, and how to deal with correlations between dielectric and in-place density. And we really didn't talk much today, but we're also going to have to look at, you know, eventually we might have 2, if not 3 different DPS carts on the site. So that's gonna add to the complication. Related to that first bullet is the precision and bias between DPS units of the same brand and also different brands. And also related to calibrating and ensuring the units are functioning properly is the need for a gold standard calibration block that can be used to compare and check units. Kyle mentioned that a little bit. Training was seen as a significant need. With any new technology, champions are needed to really speak on behalf of not only the states, but the nation to push this technology forward. As far as specifications, state agencies have different forms of specifications. Guide specifications for acceptance using DPS for in-place density is needed to assist the agencies. All right, so let's talk about system improvements desired. I apologize. Yeah, in particular, data analysis procedures are needed to be streamlined. Add real-time analysis tools such as determining current PWL or percent conformance. Add the ability to detect and analyze localized defects. Need troubleshooting tools to identify when a sensor is not reading properly. And we heard that GSSI is working on that for their technology. There was discussion on push carts versus vehicle mounted. The consensus was having options was a good thing, depending on the cost, the safety considerations, the labor, the functionality, and that was brought up again today. Any enhancements to make the system more repeatable, such as identifying moisture or ensuring consistent sensor height, would be a valuable system improvement for acceptance. And then while not specifically addressed, the need for real-time vendor support during construction was noted. And we just heard about that also. Okay, so some of the research gaps. The biggest one and the biggest issue is, and we talked about this quite a bit yesterday and today, it's that bias between the gyratory compactor calibration and the field cores. And really, to make this technology successful, we really need to figure out where that bias is coming from. Residual moisture in the mixture of different asphalt absorption with time was identified as a possible cause for the bias, you know, sometimes seen between the calibrations based on cores and pucks. So moisture is another issue we need to look at in more depth. And then also was discussed at what point do changes in the gradation, the asphalt content, the wrap content, gradation type, you know, how do they affect the calibration? And then we talked about layer thickness also, and I know we talked about that yesterday also, but it's something that needs to be considered and evaluated further. Okay. So let's talk about some recommendations, and you know, we're going to hear from Dennis and Kyle, because Dennis did talk quite a bit about the quality assurance, federal highway quality assurance requirements. And we'll talk about that more, but that was a big item of discussion during the workshop. And the main recommendation after that is there's so much to talk about. We might want to consider a small technical working group to discuss that in more detail. And with that, you might want to consider one or two other priority TWGs to focus on the high priority gaps. So with that, that's all I have. And I'll turn it back over to Kyle.
Thank you, Steve. Yeah, that's a great overview of the challenges that we're facing. And like you said, that I think the discussion that we had on the workshop that Brian set up was very beneficial for the technology. So we're going to move into the next portion, which is Dennis and I, and we're going to talk specifically about some of the challenges in trying to get DPS implemented for acceptance, and also talk about some potential solutions. And please be thinking about comments you might have or things that we might have missed, because the next session is an open discussion that's going to require a lot of participation. So please don't be shy after we're done with this presentation. So I'll share my screen now. And Dennis and I will attempt to work together on this presentation here. And I told him basically feel free to cut me off in the middle of a point or after each bullet point, because I think, you know, these two things go hand in hand with some of the technical challenges I'll be explaining, and some of the implications from a regulation standpoint, and all those things that Dennis is looking at from the Federal Highway Administration. We do have quite a bit of content here, so I am going to stop us once we hit 3:30 Eastern time. So we might have some additional slides afterwards to prompt conversation, but I'll rely on Jeff Brunner to stop us on time if we're going along here. So with that, I'll let Dennis take it away with just an overview of acceptance methods and ways of doing it.
Great. I guess you're going to see the slides several times throughout this discussion, and I decided to kind of categorize things into 3 different ways you can accept density using DPS. One is to have the agency do all the data collection for acceptance. A second option would be to have the contractor use their own DPS verified by the agency DPS. And a third option would be to have the contractor DPS verified by some other method, maybe such as using cores or a different way. So you'll see this again, and I'll talk about these 3 methods in turn as we talk about some of the challenges, because how we handle the challenge may be different for each of these methods. So back to you, Kyle.
Thank you very much, Dennis. There's, I guess, a few major categories that I'm calling minimum requirements that we have to have as part of our specification to be able to use it as an acceptance tool for density. One being ensuring that the correct equipment is used, and there's going to be more vendors and manufacturers of the equipment coming as the tool becomes more widespread. And I think we have this challenge pretty well under wraps with the AASHTO spec, but we'll get into that more later. We also want to ensure that the sensors are consistent throughout the day and project. You saw some inconsistency that's been getting better over time, but again, as more vendors are coming to the forefront, we need to have that handled with our spec, where we'll be able to ensure that we know if a sensor is getting out of spec or malfunctioning. Dielectric to density conversion is huge. It's basically what's used to convert every single measurement that you take out in the field. So if you screw up this, you're screwing up every single measurement that you're taking out there in the field. And that's something we'll touch on a little bit here in this presentation, the importance of having an accurate conversion from dielectric to density. And then, of course, once you have your accurate conversion and you have your sensors working consistently and precisely, we want to specify a collection pattern that is acceptable for use as acceptance of density. We have enough coverage. It has to be done in the correct environment, in the correct location, so that it's actually measuring dielectric and not other aspects, such as if there's water on the surface, for example, is a major one. So we'll get into that a little bit. And the thing to keep in mind is that there are a lot of challenges, but I think they're worth working towards to overcome, because if we can non-destructively improve our coverage of density and use that as an acceptance tool, that's going to have huge benefits in terms of the type of pavements that we're going to be building. So I'll pass it back to Dennis to explain some of the core elements of the quality assurance program.
Sure, Kyle. I might start out by kind of referring back to some things you've talked about that relate to that DPS, I look at DPS as a test. We have lots of tests that we use for asphalt or concrete or other materials. And every test has variability, and every test has more variability than we'd like. We try to deal with that variability through statistical methods or other things so we can account for that variability. PWL is a great example of how people have looked at variability and using multiple tests in terms of accepting material. So things we're going to talk about with variability aren't necessarily the end of the world, because we deal with this with any test. And with that, for those of you at the implementation workshop last April, you may remember this slide and some of the discussion I had about these core elements. I'm not going to go into them in detail, except these core elements also have to be addressed for DPS, whether it be how you check the personnel, the equipment, how I to independent assurance, etc. with DPS. So those are also challenges that we have to deal with at some point. So, but one of many things we'll deal with over time. And Kyle, I'll transfer it back to you.
Yeah, and I touched on this briefly at the beginning, but the spec that we do have in place, the AASHTO standard, draft standard in place, is designed to address the initial bullet there. And the challenge we face is that as more vendors and types of technology come to the market for density profiling systems, we're going to want to make sure that we have a specification that makes us feel comfortable that this technology is meeting the necessary stability measures and variation and precision that's outlined in this spec. And the only thing I'll mention here is that this is something that, as with other AASHTO specs, it needs to be reviewed as time goes along, because there's going to be changes in the method over time, and that's something that we'll plan on doing with this current asphalt surface dielectric profiling system using ground penetrating radar AASHTO spec. Now we're into the challenge of ensuring that the field collection is consistent. Craig gave a good presentation showing an example that they saw using the repeat line test, where they had two different pieces of equipment, and one piece of equipment was outside of the specification at times, and then the other piece of equipment was out of specification at times. And that's something that obviously, if the equipment is operating like that, we can't use it for our density acceptance specification. So in our AASHTO spec, and as we attack this challenge, we need to make sure that we have a method that tells us when those sensors are out of an acceptable range of each other. And we think we have a good start here with the swerve test as well as the repeat line test. We'll definitely want to follow up with Craig to make sure with that line test, when they were seeing the sensors out of spec, that the line test was doing what it was supposed to and the sensors were actually out of spec. That's one of our challenges. But certainly that's something that we need to gather data as a group and work together on this technical working group to make sure we're all happy with the way we're catching it if a sensor is not functioning the way it's supposed to. And an example of that is, initially we were thinking high density polyethylene as a standard, similar to what we used for the equipment spec, but the early returns on that are not promising, in the sense that if a sensor is working properly with the HDPE, that doesn't necessarily mean it's going to work properly for the asphalt and vice versa. So one thing that Steve briefly mentioned is we're looking into other materials, because really, as good as the swerve test and the line test is at measuring consistency, they do require multiple sensors, and they're not, strictly speaking, testing any sort of accuracy. Whereas if we had a standard material like a garolite that has a similar dielectric to asphalt, that might solve a lot of our problems if we can implement something like that. This just gives an example of one of those situations. We could also put some of those plots that Craig was showing in Ohio of an example where we need to have a plan if something like this happens, where sensor 196 was in spec at the beginning of the day, and by the end of the day it was measuring too low, so it had to be corrected. And that's something that we need to have a good agreement on what to do in those situations. Do we need to just require recalibration until it works? Can we justify standardizing the sensors based on a swerve or a repeat line test, where you basically just normalize the sensors to the median of the global 3 sensors you're using? Or do we just need to revert to coring, and how would that affect the logistics of our density acceptance if we're having to revert back to coring at times? So, and then in addition, in order to be able to make those assessments, we have to have the data, right? So we've been trying to move towards limiting the amount of consistency checks, because that's basically taking away from our routine data collection that we want to use for our density acceptance. And the question is, you know, based on the data we're collecting with the technology, is the beginning and end of the day enough? That would be a good scenario to be in. Right now, we're not that comfortable, and we're hoping to continue the consistency checks every 4,000 feet or 4 hours. But anything here needs to be justified by the data, and it needs to be justified quantitatively, not just by feel. And of course, if we're using the contractor collected data, we need to have a way of doing a random check or random sampling with the agency device, which we're going to discuss in more detail later. Go ahead, Dennis.
Thank you. This is going to start out by saying that these are 3 examples of way you could accept using a DPS. They're probably not the only things you could ever think of, so don't assume these are all inclusive. But in terms of everything, we need good data. So no matter what method you use, you need to make sure that we address the sensor issues as Kyle talked about. And then back to you, Kyle.
Okay, so now we're into the challenge of ensuring that our conversion from dielectric to density is accurate. So like I said at the beginning, this is from a process point of view, possibly the most important step for us, because like I said, this is the process that is going to be applied to thousands of data points, that conversion from dielectric to density. So if you're off by a couple percent with this, that's going to be applied to your entire data set until you recalibrate. And that brings up some somewhat major issues with kind of the traditional solution of developing a correlation with field cores. And this has been, like I said yesterday, the way that it's been done since the 1990s to convert from dielectric to air void is to go out and actually cut holes in the pavement and measure the density of the core and compare that with the dielectric that you measure before you cut the core. And just some things that need to be considered if we ended up having to go with this traditional solution is, you know, how many cores are required to develop an accurate conversion? How do you specify core locations to ensure you get the full range of cores, considering unlike with the production mixed pucks, you can't pre-specify that. You actually have to find those low and high void locations. How often do you need to do a new conversion curve? How do you accept or reject your core develop dielectric to density conversion? And how do you create your conversion curve and test the accuracy without taking too many cores in your pavement? And those were all difficult questions to answer.
And thanks, Kyle. I'd like to say I've been involved with asphalt paving for, I guess, 30 or 35 years. And at that, going back into time a while, now a lot of states were using a nuclear gauge, so you correlate the cores to try to get density. And in many cases, of course, as we're all familiar, the cores you're getting don't really reflect the total spectrum of density on that pavement. So the correlation may not be accurate at the extremes. Maybe at the median is fine, but not at the extremes. So that's a weakness if we're talking about using DPS, that we're going to just really have cores covering a small area of what the real paving is. And again, as I talked about last time, we need to have, if you're going to most states have density specs. So as a result, we need to have, my goal would be to have us use the same type of spec we're already using in a state rather than create something brand new for DPS. I would add though that if you're creating a correlation, the agency needs to be doing that for their DPS and not rely on the contractor say, this is your correlation, whether it be with cores or specimens or whatever. The key is that, because that's going to drive what the result of the DPS density data would be, which is then going to drive incentives and disincentives. So with that, Kyle, thanks.
Yes, so now we're ready to move on to what we're currently trying to achieve with our pooled fund, which is developing that correlation using the production mix gyratory samples. It addresses a lot of those issues that we talked about with the traditional way, where now we're non-destructive in a sense where we're just taking material a lot of times that's being used for quality control anyway and measuring the dielectric there, and then just getting our additional predefined medium and high void pucks to create our curve from dielectric to air voids. And in addition to ensuring a full range of air voids, what we've found so far, and the UNH study and even some of the stuff NCAT is doing is confirming that the dielectric measurement is extremely stable from sensor to sensor. From a repeatability standpoint, it's a very precise dielectric measurement of the mix, and we found it to be fairly easy to integrate into the process, where basically the field operations are not disrupted, and you just have the tech who's doing the gyratory compaction shoot the pucks for dielectric. And as Ishan touched on, this does have potential value beyond just what we're using it for, which is a way of monitoring our conversion from dielectric to density, but also can give you important information about the mix from a quality control point of view. So we still have to answer the questions. We can't just say it's very consistent from sensor to sensor, test to test. So the question is, how often do we have to do our repeatability tests? Right now, we're just doing every single specimen, measure the top, rotate it 90 degrees, measure the bottom, and make sure it's within 0.05 dielectric. The high density polyethylene appears to work for this, although I'll say we have less data of sensors being out of spec with this method, so we can't necessarily say just because it's within spec for HDPE that it's going to be in spec for the asphalt samples as well. So just something to consider. We are being somewhat lax with what we're specifying right now, which is basically hit your design voids regardless of what they are, and then remove mix and gyrate to the same height. That's something that's going to need to get tightened, and we need to do a little bit more evaluation into the variability that's occurring on those higher void specimens, and maybe look into looking between 2% and 10% voids, because we know everything over 10% is bad anyway. How often do we need to monitor things? Generally, it's a pretty low cost operation to just shoot all of your samples for dielectric, but putting together that spec from a regulation point of view, we need to make sure we're catching it if there's a change in mix. And there are sources of variability even in the gyratory process, and one thing that is extremely sensitive is what we're using as our input thickness. Just a 1 millimeter inaccurate measurement of a gyratory puck thickness is a percent air voids or percent GMM. So we need to have a standard for how that puck is measured for thickness, and so far the readout from the gyratory compactor has been good, but we need to know how often do those compactors need to be calibrated for outputting the thickness. Does it even work when we're specifying to gyrate to a certain height? If it finishes a gyration after it's already hit that height, those sort of things need to be accounted for in our specification, and that's a challenge we're looking into with some of the different methods that UNH has looked at, and Rich Giesel in Alaska has done some things, and we're doing some things here with our touch probe gauge to check the accuracy of the thickness of the puck. Go ahead, Dennis.
Well, thanks. This whole discussion about measuring thickness of the gyratory reminds me of a few years ago, we had to change how we measured the internal angle within gyratories. So it may require that there are more requirements on thickness in gyratories for an annual calibration or things like that. But I think it's all doable so we can get good and accurate thickness within a gyratory, hopefully. But kind of following what I said last time, if I'm using agency DPS or I'm using agency DPS to verify a contractor DPS, the agency needs to be performing this puck calibration. That's not something the contractor can do since it, or should be doing, because it's going to directly impact payment potentially. If a contractor is using their own DPS in the second row that I have, they could do their own if they wanted to, and definitely in the third row where they're using their DPS where it's verified by some other method, they could also do it on their own, because in the last case, if I'm using some other method besides the DPS to verify what the data the contract, density data the contract is providing, I don't care whether the accuracy is, whether it's accurate or not. I guess I do, but we have another mechanism of checking that, whether it's accurate. So back to you, Kyle.
Thank you, Dennis. And this gets us to kind of the most critical thing with this process, which is basically checking the accuracy of that conversion. And this has some challenges both logistically and technically from an accuracy point of view that we've observed so far. But one thing to keep in mind, we keep talking about laboratory versus field bias, is that by and large, we're getting very good results. We have a very high percentage of the time when following the protocols that we're specifying as part of the pooled fund, very good results in the agreement between the field cores and what we see in the dielectric to air void or density conversion. But we need to be picky here, and we need to make sure we're accounting for situations where there is bias, because you can't just say, well, we're good 80% of the time if you're going to be using this for acceptance. So, you know, I've just listed some of the challenges that we've faced just with the logistics here in terms of making sure we're getting an accurate dielectric measurement before the core is being cut, and trying to do that in a way where we're not adding additional cores to the process itself. So I'll just leave those there in the interest of time. I think we're 5 minutes out from needing to move to the next session. You know, again, just listed some things that we've tried that we wouldn't recommend. This would be doing our measurements the following day, which is susceptible to wet pavement and moisture issues. We also have considered for next year not necessarily worrying about adding additional cores for a year, just to test out an alternative method, which would be to use the DPS itself to select core locations, not in the sense that you're trying to cherry pick locations, but you would just randomly select within locations where you know you've already measured. So that's, you know, another thing to look into and try to address that challenge of getting enough reliable data telling us if our conversion from dielectric to air void or to density is accurate. And that would require an accurate GPS and some of these other things that I've listed here. And so now we get to the point where we have a logistical way of getting the data that we need. Now we got to start asking questions of, and I think Craig mentioned this and many others, is what is good? You know, how do we quantitatively assess agreement between cores and prediction? And kind of, you know, what we've been doing the last couple of years is just as a rule of thumb saying, okay, we'd like it to be within the 0.03 GMB criteria, which calculates out to about a 1.2% air voids with our predictions, just because that matches our companion cores for agency versus contractor. But UNH is going to look into that as a statistical acceptance criteria and give us recommendations on that with their contract. But that's something that I think as a group we really need to look long and hard at is, you know, what do we consider to be acceptable to be able to use this tool for density acceptance. And the same thing with the sensor consistency is having something in place for situations where there's not good agreement, where there is a bias. Are we able to standardize our prediction to match the core results? And if so, how many cores are required there? Are we able to stomach having a little bit of bias from time to time and do what we kind of are doing now, which is to say, yeah, we know we're not coring enough to accurately assess the overall compaction, but over time it'll even itself out. Could we do something similar here where we say, yeah, we're going to see bias from time to time, but you know, if we paid them too much on this project, then we'll pay them less on the other project. I don't know what type of a stomach we have for that kind of an implementation, but that's just questions we need to be asking. And with each of these things, you know, how many cores do we need to have to check accuracy? And I think that's a function of the results too. So we need to look at that. And I'll move it back to you, Dennis.
Thanks. I'll keep this quick since we're almost out of time. Obviously, we could adjust that correlation to cores if we have enough cores. Obviously, if I have one core, that's not enough to really be comfortable with that delta or that change. If I have 1,000 cores, that's probably more than I need. I think there's plenty more research needed in that area. I would note that we've had states that have inquired about using cores and having a DPS check that core in the field as a measure, location in the field as a measure of whether or not the their verification of the contractor DPS. My concern with doing that is that we don't know if the DPS is running, giving the same data in terms of being set up the same when it's checking that core at a different time versus when it was run for providing density for the entire day, let's say. So as a result, we need a independent verification showing what we have. With that, Kyle, thanks.
Yeah, thank you. And getting into the ensuring the routine collection is used for acceptance evaluation, that's done correctly. I guess the main thing I want to hit on here, we've hit on a lot of this stuff already, that, you know, at the end of the day, I think this would be an example of just to note here about this plot that I'm showing on the right. This is a zoomed in 4,000 foot stretch of 2 miles of that were collected that day. I just wanted to have this as an example of how we might handle some of these issues, whether it be different manufacturers or contractor collection and agency verification, where as long as you have both pieces of equipment calibrated to the mix to output density, you can do the random sampling approach, where here we took a random 3,000 foot stretch just to evaluate how close our results are as an agency to the contractor collection. And ideally, I think this would be done in terms of how you're speccing the acceptance. So if we were using 150 foot sublots to do our density acceptance, what we would want to do is look to see if there's a significant difference between if we were to use the agency data along this stretch versus the contractor data. In that case, to a certain extent, you don't care what the manufacturer device is. You don't care who did the collection. It's either it's doing it correctly or it's not. And that's, you know, similar to what we're doing right now with cores measured by agency versus contractor. But with that, we're hitting our end of our limit here, and we do want to get on to the next subject, which is just an open discussion. I'll stop sharing my screen here. And with this section, it's basically the goal that we want to get to with this last 30 minutes here of our time together for this event is to, one, identify people who are willing to put in a little bit of time in meeting on either, you know, every other month or quarterly to attack some of these challenges that we've been discussing today. And then I'd also like to open the discussion for anybody to give their insight, either further perspectives on some of the things we've discussed already, or identifying some topics that maybe we haven't thought of. And then at the end of this meeting here, we'll compile a list of volunteers to send an email for a kickoff meeting to, and then use the information from both what Steve has shared with the DPS roadmap and then some of the additional insights we've got from our 2 days here, as well as the vendor event next week to try to kick off what topics we're going to be looking at as a group, and then who might want to champion some of those specific topics. So with that, I think it would be great if you're willing to be part of the technical working group, or if you have any questions about what that might entail. I think now is the time to ask those questions, and if you're willing to at least commit to receiving an email, you don't even have to accept being part of the technical working group. Please put your just TWG : and then your email in the chat, and we'll record that and make sure you're included. It does look like there's been some comments here while Dennis and I were talking. Di, I do want to give you some time here to add anything I might have missed or catch us up with the questions that have been coming in. So go ahead, Di.
Sure. Just a couple of thoughts on here when I listened to Kyle's and also Greg's talk presentation, other people's presentation. For the this buyer's issue of this job, the verification core versus the laboratory calibration line in there. The car said most of the case worked fine for us on the projects, but some days did not work for us. Another, we talk about the source. The possible source could be related to the thickness of the layer thickness. One project, I think it's the Triangle Highway 30. We did see most of the buyers came from the base lift. So we thought that there may be some thickness, it's 1.5 inches, I believe it was the design thickness 1.5 inches. But during the paving process, may not be perfectly 1.5 inches, some higher, lower spots. So that was the thought in our mind. So I guess we reached to the JSSI, say it would be much better if when the output the actual constant measurements, but also output the thickness as well, because the GPR have capability to determine the thickness as well. So I guess that probably is the things. I guess as a group we can make suggestions for GSSI to make an improvement when we talk to them next Tuesday. I don't know, so what I think that the group can talk about during this TWR meeting. That's the one thought. Another thought is this geometry pocket thickness measurements. And the car said that for right now we're using a very precise this gauge. It's kind of automatically locks down the readings when the probe touches the surface of the POC. It matched pretty good. That really matched pretty good with geometry mold measurements. But sometimes, like this, Eric talk about this rubberized the asphalt mixture, and that kind of tends to expand after they compacted. So that's something we need to discuss also too. See at what time this expansion after compacted expansion stops, and then we can take a good measurements. So that's something I think some people, I think Leslie mentioned about some other states using rubberized the asphalt for the projects. So those are the things come into my mind. I think maybe we can talk about as a group. So
Yeah,
any
great.
suggestions, questions, comments from group?
I'm really happy to see the list of people so far who've who've agreed to be part of the technical working group. I think obviously if we can fit people to the different categories that they're passionate about or they have expertise in, I think that'll help too, to make sure. I did want to use this time to discuss a little bit the format of how people think this should go. I could see, different ways that we've discussed with Steve Cooper and Dennis and Kevin. You could have separate meetings for separate challenges. I think at this point, there's enough probably overlap between the subjects and the people who are interested in attacking the subjects that we could do a single technical working group, but just have people assigned to make sure that we at least touch on each of these different topics that we find to be of interest at each of our meetings. So I think, one thing that maybe we should talk about today is the format of the meeting. Is there any strong opinions on if we think we could put everything into one technical working group and hit on some of all the different topics as we meet every couple months, or if there's an alternative way that you'd like to see that done? Irv had a good comment to have a single technical working group, but yeah, have subcommittees. So basically, if there is a topic that people want to meet on, if there's a subcommittee, for example, on gyratory compacted test protocols and some of the factors that might affect your dielectric to density conversion, and we're not going to meet for a couple months with the larger technical working group, I think that's a great idea, Irv, to have a subcommittee that the champion can call a meeting between those. And one thing I want to be sensitive to is that we have a lot of busy people who will be really helpful to take on these challenges. And I think that suggestion, Irv, helps us with that challenge, that basically if you feel like your subcommittee or the topic that you're championing just doesn't have time to meet between the larger group, you have that flexibility too. But I do think we're getting enough expertise, and it's nice to see more and more states using the technology that we can, and contractors, frankly. And I think after next week, we'll probably want to include the vendors as well. Is there anybody who has any comments on the makeup of these technical working groups? If our current thought process is to include vendors and academia and whoever's interested in advancing this method, is there any comments on advantages of restricting that, or are we fine opening it to the different types of groups or stakeholders in DPS? It looks like Leslie signed up Massachusetts and Arizona, so I'll hold them to that. And we've got a lot of good volunteers so far.
Yeah, sorry, Kyle. I put that. I don't want to say that. I put them in there for because I think Guy said about some states had asphalt rubber type mixes, and so I know Massachusetts did measure. I don't know if Maggie's still on, but I think they did hit one project that had that. And again, I know Arizona uses a lot. I don't know whether Nye has had the device out on that yet either, but I noticed somebody else put in there earlier about like it would be good to have University of New Hampshire potentially look at these different types of mixes. We have data from SMA projects. I think we've got maybe 2 SMAs now, and so we've got some deep. But the question for us, just starting out, is how good is our data? We still have a good enough feel on that. because each condition is different, especially like Michael Bond was talking about the experience in Wisconsin, right? I mean, like when it's a lone experience, it's very different than when we were with Jonathan Stark for a couple days in North Dakota, side by side for, 4 days straight. Like that's a different experience than kind of taking out, training a DOT, leaving them with the equipment and, just getting the data a month or so later. So it's I think something our experience probably is transferable to if you're thinking about a state DOT where you're dealing with your different districts, right? So talk about Hawaii having, several RDMs that they purchase, like, how do you, it's probably not all that different than the experience we've had with the loan program, right? You're kind of sending your devices out to the different districts. I mean, there might be different conditions. How are you going to best assist from a central office in that scenario? So I think I don't think, like Dennis, I agree with Dennis. I think we're still very much at the research phase right now. But once it gets to that next phase of we're talking about real, pilots and implementation, like how best organizationally do we deal with that scenario? I think it's going to be an important discussion point in future with this group.
Very good stuff.
Yeah, that's good. Okay, I see the Kyle Buran from the Hawaii is here now, and I think we had the round robin this morning. Kyle called it round robin. Maybe you missed it. Kyle, do you want to say something about the Hawaii's program? Okay.
We did have a couple more comments. Robert Hinman says might be. Oh, is Kyle? Kyle, are you starting to talk there? I see your screen lighting up.
Yeah, I guess we're not too far along. I would say we're having trouble. I guess trying to figure out how we're gonna fully implement. We've introduced this to inspectors, and they were very concerned, to say the least, in regards to their current manpower and who's going to be running this. And I guess we're thinking of just subbing it out to contractors or consultants. Well, other than that, we tried doing it on a couple projects, and I guess something was wrong with the calibrations, because quite a bit of our sensors were outputting lower than expected values during the calibration process. So we're trying to figure out how to resolve that.
Very good. Thank you, Kyle, for the update. How many do you have? One device or?
So we have quite a handful. I think we have at least, well, that I've seen and that I'm aware of, we have at least 4.
Okay. Okay. Thank you very much.
Yep. Thank you.
We had a comment from Robert Hinman that might be helpful to display the list of areas that work is still needed to try to bin those areas together. And I think that's going to be the kickoff meeting, Robert. I think, what we'll do is we'll compile a list of priorities that have been identified with the roadmap workshop, as well as the great feedback we've gotten from these 2 days. And I think we'll go into that kickoff meeting for the technical working group with a list and like you said, try to bin those into subcategories that we can identify champions to make sure we're making progress on those towards getting this technology deployable, and then maybe even kind of prioritize and rank things that need to be accomplished. So we have a couple comments from Harold on Quintus. Very good meeting. I learned a lot through discussion. Oh, yeah. One of his comments was asking about the video, and thank you for responding to that, Lauren, that the video will be put on our website, and I'll send a email.
Oh, I sent the link under the box, chat box. So it will be in here.
Okay, yeah, it'll be on that website. Yep,
Yeah.
that's right. And we'll send up a follow-up email about the location and in the YouTube channel. But Harold said it's the way of the future, in his opinion, will be one of the cost-effective means for forensic investigation as well as QA. So does that mean that you're signing up for the technical working group, Harold? I don't see your email yet. He might have left us already. Leslie said that MATC is available to assist Hawaii, so that's good to know. Harold, I saw you lighting up.
Yeah, Kyle, I will.
Awesome. Put your
I'll
email in
start.
that chat box then. And if you put it there, that just means you're going to get emailed about the kickoff meeting and whether you
Oh,
accept
good.
it or not. So
That's good. Great.
yeah. So we still have 12 minutes for discussion. Is there any other topics that anybody wants to touch upon? I know it's a long 2 days, and we've had some really good discussion, really good questions, really good participation. So I appreciate all of you for sticking through these 2 days.
So another thing I just want to point out is what I heard, like we do the joint management about 6 inches away from joint, and
Yeah.
Rich Giesel does the joint management over the top of the right on top of the joint, and some of the North Dakota does that too. So we're doing kind of different things. Maybe we should talk about should we come up with one common method for measure the joint. That's something we should talk about, I guess. Oh, somebody raised a hand.
Yes, I saw Ken raise his hand. I'll let you go first, Ken. You have some thoughts?
Yeah, thank you, and what a great meeting, by the way. I just had a couple points, and probably is now the time to add them. Is one of the very important things, and for the pool fund study to look at, and I know it's probably phase 4 or 5 down the line, but technically it would be called ruggedness. And I know it was mentioned yesterday, but ruggedness and reliability, if you look at the Gen 1 of paper mounted thermal profilers, for example, where they were mounted on the screed walk, is I was around a number of jobs with those, and you got crews that are working 12, 14 hours a day, 6 days a week. It's 100 degrees in July, it's 45 degrees in October, and it's constant, on and off when they were doing that. And ruggedness is very important because that also leads to reliability. And if something doesn't work when it's supposed to work on the construction side of things, people buy out as quick as they buy in.
Yep.
And so taking a look at that, I think would be extremely important. The other thing is on the traffic safety side is maybe the way to break it down. All the speakers did a good job, especially those that have used it a lot, about the limitations. And what always came to my mind was ride quality, ride measurement. Was when that started, if any of you are as old as I am, and you had to push a California type profilograph or an Ames profilograph, right? You were doing that under traffic with human power. And that quickly accelerated to motive power with side-by-side or mule-based systems. And then, of course, now to high-speed profilometers. And the thought occurred to me is that evolutionary chain will probably continue with DPS. But if there was a way you could tie it, like right now with ride quality, is you put the laser heads on a pickup, tie it into a computer system. Well, if you got the laser system, what's the difference of having a GPR system as well? Almost like a rotating rack on a truck, right? I'm measuring ride now, I'll measure density later. And I could see it evolving to that actually relatively quickly, and that bypasses some of these safety concerns, traffic safety concerns. In the other thing about that is the QC versus QA application. We spent the afternoon talking about QA, and that's important, obviously, from an acceptance standpoint. But I think Bryce did a really good job on the QC side, saying that, you know, you don't necessarily have to have an exact system. You just need a system. You know, as we saw with longitudinal joint density, once we started looking at them, the Hawthorne effect took hold. And just because we were looking at it, longitudinal joint densities went up. And now that we're measuring it as well. And I think we need to kind of separate it out that, you know, QC to me should be priority one from a bias standpoint for using the DPS, because that'll drive the train. And then having QA ready, set up and run. That's kind of what happened with ride quality as well. When you look at the chain there. And then the last thing is see, this way I don't have to be on the technical working group either, Kyle, is to tell you everything I know in 40 seconds.
No, this just is more reason for you to be part of it. Follow-up questions.
I want to bring up the elephant in the room. And the elephant in the room is paying incentives to encourage the process, as well as obviously balancing disincentives. But if they're tied to the actual improvement in pavement performance, that'll move this thing faster than anything else. From a contractor standpoint, from an equipment supplier concept, I mean, Bryce already kind of mentioned, you know, they're doing it on airports, they're doing it, and NIC was kind of the same way, is once you've kind of established the value, you know, that's the way America works. So I think the elephant in the room is that we really need to tie density incentives, reasonable and achievable density incentives, into this process. And then you really, I mean, it's the best accelerant known to man is incentives and distance, and women. I meant man in the broad sense. So that's all I have.
Well, Ken, you got yourself into trouble now because your comments, you know, our office director and research manager just thought your comments were great, and Robert Hinman from FHWA agrees. So I think you're signed up. I apologize, but you're part of the technical working group. I want to get to Brandon Brever here from MAPPA here in Minnesota. Any comments you have would be great.
Yeah, no, a lot of what Ken said were good too. I guess the one thing I kind of wanted to bring up, and this is kind of a general comment on more from the lens of maybe kind of more the smaller contractor that doesn't necessarily always does DOT work. I know there's a handful of them I meet with all the time, and some of the heartburn with some of those guys is you know, they'll bid 1 or 2 MnDOT projects a year, and it's always challenging to justify purchasing the equipment. And on top of that, I mean, the safety thing aside, I think that having another person on the paving train that would have to do this full time would be kind of a showstopper for them. I know workforce has been such a difficulty, and just getting another person, it's not really that, won't really be a part-time position either. So I think that's one thing I just wanted to briefly touch on. I think the other part I wanted to, I mean, I know Ken talked about ruggedness of the equipment, but also redundancy. I mean, when I think about it, I know there's a lot of contractors that just buy brand new pavers, and they might bump that other paver down to, you know, a parking lot crew or something along those lines. But you really need, if the equipment is being utilized, that needs to be consistently used. I think that keeping it, in that tip-top shape is important, and that it keeps working and doesn't have any downtime. So that was kind of, Ken sort of touched on the other things I was going to mention too. But yeah, no, good, really good presentations. Appreciate the work everybody's been putting into this.
Thanks a lot, Brandon. That's good stuff. Yeah, especially with the workforce, that applies to the contractor and the agencies. You know, we talk as agencies, we don't have the workforce to do it and offload it on the contractors, but you know, there's workforce issues there too. And like I said, if we can get this autonomous, that would be great too. we have time for more. I see Nye has his hand up.
Yeah, thanks, Kyle. Those were good comments from Brandon and Ken, kind of, more broad reaching. Mine kind of goes back into the weeds a little bit.
That's what I do too all the time.
So I apologize for that at the end of the meeting, but for the puck calibration kits, those that are using that for their calibrations, I guess we've all probably noticed there's quite a bit of redundancy in that procedure with the background and with the metal plate scanner reading. And I'm wondering if there's any work being done to see if we can kind of reduce that to once at the beginning and then maybe once at the end of scanning in all your pucks to try to simplify that process and save some time.
Well, you stumbled upon the best segue possible. You were in the weeds, I'll admit that, but that is a great question for the vendors for next week, because the only thing I can say is that they're using the metal plate calibration to calibrate the intensity of the signal that's coming out. And then they're doing those other plastic measurements to eliminate noise. But the manufacturers themselves are the only ones who could really answer that question and say, will we still be able to achieve that redundancy and that accuracy that we're seeing when we do those tests if we removed them? So I think those are the sort of questions. Bring them next week when you go to that vendor meeting next week, because that's, the other part of this equation is we got to have equipment that's doing things that we need and doing it in a way that's logistically possible for us to do. Because I agree, if we can eliminate some of those steps, that'll go a long way for a technician who's doing this measurement every single day on every single puck. So great comment. And that does bring us to the end of our day today. I really, really appreciate all your guys' time and great participation, great questions, great presentations. So thank you very much. And thanks again to Steve Cooper and the people at Federal Highway who've helped us organize and put on these events. So anything else to add, Di?
No, that's all.
Yeah. Well, enjoy the rest of your day, everyone, and we'll be in touch with a follow-up email with some of the items we've been discussing.
Yeah, thank you. And
thanks.